I think we're going back to YouTube. So let's see if we can get some actions to do some things. We chose action. So we have 9 possible choices. And then where is... I'm like struggling really hard right now. So the chosen state should be 0, and the chosen target action should also be 0. But our targeting system, it'll have a pool of targets. We'll be able to do some action, and we want it to have some state. Let's import a state. Let's say state dot alive. So I feel like state should come from the cosmos, but if we do that, we need to put all of agency in the cosmos as well. And I'm not sure I want to do that yet. But because we have a targeting system here, we don't need the target action. Excuse me. So when we choose a random state on the azimuth level now, we can do that and then define choose random action. Um, it's not here. It's the targeting system. Self.action. Where's action step? Um, um, target action. Targeting system, random action. And then self. I don't know if we should do it like that. Like, it would really be self random action. Returns a random. Target action type. Log level shows a random action. Cool, and then we can like do actions and stuff. Okay, so when we do an action, if we are moving I don't want to just do random stuff right now. I don't know what update state is either yet. Forgot. It's not showing up. But we are gonna choose random state, choose random action, and then we are going to go back to our main. We're gonna turn all these off and we're gonna try to run the world. Unit has no attribute target. Cool. Selected equals XY. And then somewhere else we say if it's not a tuple, we just exit. Um, where do we get our XY from? From the azimuth? From we get it from the cell. So there's so many pieces of this thing. Like so many pieces of this thing, it's crazy. I kind of want to put my camera like down low, down here. I have another camera, but I actually want to write a program that when I turn my face this way, the camera over here gets me. But when I turn my head this way, this camera gets me. But nevertheless, unit has no attribute target, so we can give it a target. Go to society. We'll do self.target. Move action.random. But we don't want to say target. We want to say move action. This value is bound to the mouse hook that allows us to set selected to a tuple, then unit. And it's still not target. It's in move action. And that's still, still don't know how that works. Now that I think about it, this is just like a random, all that does is give it an X and Y. It's a random. We need a better term. Target direction. We're gonna say cursor. Unit has no attribute move action. Well, that's fine. Unit has no attribute target. That's fine. If the cursor is none, then if we're in a needy state, there's so many pieces of logic all over the place. Target has no XY. Target 1 if is instance tuple else target XY. How about like that? Move action is not subscriptable. What we'll do is we'll say if is instance target tuple else. There we go. Well, that's interesting. The age is increasing. The health is not changing. They're randomly changing states, which is cool. But why is their location broken? Excuse me. Yeah, I was wanting to get this in here too. No target named for real life. Well, that's because we don't need a target named that. Okay, so let's do settings. Let's find our settings. I don't know why my voice just dipped like that. Let's go to verbose. Let's log everything because we need to see why our units are like spawning in this. Choosing a directional vector. Let's go back to the start. Let's clear out the screen, run it, and cancel it. There we go. So we created a society. We created a genome. I'm not sure why it says that twice, but maybe we reinitialized it twice. World, genome, society. I wonder why it says it twice. Creating genome, creating genome. Oh, it initialized itself. We should have called it statically as such. So it created itself as a member of itself. Populating society. Grid size 10, total grid count 100, spawn area 1 to 1, population 2, markets 1, homes 1, and then we have a So here's where we're updating population down here. But that's not what we need. I could move some of this to like debug, but it's fine. I kind of can't believe that we don't have. I guess we have everything commented out. Let's go. Let's just go to. I know where we want to go, but having a hard time finding the words. So when we get here, we're just going to how about we just define log state and then see what excuse me. I don't know if I want to. It's really hard to see with all this stuff like this in it. I guess it is hard to keep up with all this stuff. Let's see if we have a string function for this unit. I don't think we do. I know the azimuth has a string. We could just say define string self and then unit I actually want to say log log level debug unit I almost just want to say self just like that. So there we go. So then it tries to call itself over and over again. That makes sense. So let's get our XY. And our ethics XY. Because we're not calling it. We could say print self just like that. Self.xy. Yeah, I'm gonna have to go after this. I don't think I'll be able to make it much more. Yeah, so there's our unit. I don't know why it's at 1 and 0 though. Oh, because their IDs are 0 and 1. Um, we need to say look at that. Look at that. I want to just look at it. So we can take settings. Let's go back to settings and turn our debugger to debug, and then this will allow us to clean up all this verbose output. So we can see all of these are cells. Yeah. Cell 0 is a home. So this is them doing them in parallel. So we create cell 0, and then cell 1 is created as a unit. So I wonder why. Because at a cellular level, we get a random location. Get a random integer. We get an XY, we'll say creating cell with type log alert. We'll put this at info, and then creating. Yeah, we already know we're creating the cell. We'll put a tab here, and then say x self x, y self y, and then yeah, that should be it. Of course, these should all be cell. So that's our x and y, 3 and 5. Why is it drawing? I don't understand that then. I love that they have like random emotional compasses. It doesn't really look like much, but where are we doing this? Um, when we get ethics XY, right? Um, let's define ethics, and then we'll just return types. And we'll define ethics dot ethics names. Okay, let's try that, and then let's see where we get ethics XY. We will change this to name. Is a cell. Let's go ahead and comment out this logging here. Then don't understand why they're stuck there. Kind of doesn't make sense. Um, I don't know. See, like we could do this. Um, see, it says I'm drawing the male 7-3. I'm clearly not. I understand. I'm missing something. Y size radius. I'm so confused. Like, this unit type is inherited in the cell. Like, we've got a pretty extensive hierarchy right now. Which, that's a program I wish I had. Um, hmm. Just not understanding, like, I can't imagine why these things would draw, but not here. Like, even the circle is drawing off. So, like it says it's drawing the female at 1 and 5, right? It doesn't make any sense. What? I don't. We're not doing anything different for a market than we're doing for a female or male. Like, fuck. I wish I had somebody tell me what to do. I almost feel like I should take a break, but because I'd like to integrate these things into moving again, like having them randomly choose actions. Because initially we do want them to randomly do things. We want random stuff to happen and rewards to get pumped into this network. Oh, is it because of the cell size? Is the self size changing? Oh, look at that. So we have to say pool size. Ah, the target system was overriding the other variables. Ah, this is why it's very good to be explicit with variable names and not use generic names. Ah, look at that. Much better. Cool. Cool. So now, let's see. Let's see if we can do this. Let's see if we can log alert. Pursuing per pursuant. And then, log level alert. No action taken. Okay, and then we're gonna take this other one that we had. Damn it. Shit, fire. We're gonna take this other one that we had. This one, this alert. Where we're saying that we're drawing. And we're just gonna comment those out. I don't know if we even need those. But it is kind of nice to have that if we do need it, so we'll just leave it. Okay, so let's just make sure we are actually hitting log performing action. So let's see if we are actually doing an action. Okay, we're not actually doing actions, so that is a thing to consider. So every time we do an action and they lose points, they're gonna see that there is a reward for doing nothing. So that will be very cool. So we need to go back to our main loop now. We need to start at the top level of the world. When we run the loop, we call this main update function in the world. It's inside the loop. So now society, we want to say self-draw units. Self.update units. So we don't have that. We should have that. Go to society. We look at update population. Now, I don't know where update population was being called at. That's in the engine. We're basically just going to move it to world. And we'll pop the selected in there. Look at there. Now our code finally comes home. So, updating world. Let's just make sure we are in fact hitting here. There we go. Updating world. Excuse me. Let's put this after this. So this is a callback function. This is a callback function that we pass down to the engine to give us a higher order of control. That's right. So this updates the units, this draws the characters, markets, homes, or should. So when we update the units, we want to change this and say, yeah, okay. If unit action the action. Okay. Define content self return self.action equals target nothing and state equals alive. So this could have a positive reward, could have a negative reward, but we do want to just check for that. This will increase our happiness, and also our compassion. So we can actually, when we update our units now, let's close this. We can actually build our main loop now. This is amazing. This is amazing. So we could say if unit dot content, we can say unit dot happiness +1 unit dot so our ethics system, where is that at? Can't believe we actually have like ethics in the game. Let's put the matrix over here. Cool. So integrity points, compassion. It's compassion plus equals 10. And then gain compassion 10. Okay. You would think these contradict each other, and they do. But we'll only do this if the life's already sucked out of you. If the action... Todd totally got distracted. If the action equals target action nothing, we need to do that. Here. If selected, we'll just continue. That's right. Um. Define Wu Wei. This is amazing. This is amazing. Doing nothing. Literal doing, not doing. So it's funny how much like programming is silly. Unit has no Wu Wei. Let's see. So we don't have a Wu Wei because our targeting system, we should update units, self units, unit and self units. Society just has some units. Go to this. You know what I'm saying? Like this thing should create units. Units should have a Wu Wei function. Targeting system. Oh, did I not save it? Okay, so they age. They don't do nothing. Like if we log warning Wu Wei, then we should see Wu Wei. We're hitting it twice, it looks like. Oh, because we have 2 agents. So I wonder why though. Why is it Wu Wei? The default target action, nothing. So we will kickstart it. We can say on a societal level, if we are broke, hungry, the magnitude is 0. Otherwise, we want to update state. So we gotta find this on a unit level. This guy over here. Close all these suckers. Close all this. Open it as needed. I think we have this azimuth level we can integrate on. I really should build a diagram. Let's do that. This would be the responsible thing to do at this point. So documentation is probably one of the most important parts of programming, I think. We will call this program Wu Wei. I've been calling it for real life, but I don't know. Maybe we will call it for real life. I'm open to comments if anyone has any ideas. Hello, Lappy. What's up with that? Charmander. So, we're going to try to define our hierarchy real quick. We'll come back to what we were doing. The world inherits genome, society, and an engine. And we need some tunes. Give me a second, I'll get some music going. So this world in our society, we have put this right here. Appreciate the follow, Lappy. So our society has we really should put the world up here. And we should do something like this. I'll have to move it one more. And then our society has units. This is volumes. Come on now. There it is. So we got units. We got homes. And we got markets. We'll send this one to the back. And then this one to the back. Then we'll connect this one to this one. This one to that one. So that's good enough. We know that we've got these lists of markets, homes, and units. And then it might be worth mapping out where the rest of our program is, because we have our population. Oops, I messed this up. If we go to our populate function, we can see, so we're using multi-threading to create all of these at the same time, so that we can create them in batches at scale. And so we have a population number and a unit type, and then we're passing these into our helper function. So our helper function takes in a type and a number of types, and it just creates a list of that number of types. So that's how we generate all of the types in our program. So then what we're doing is we're creating a list of units, markets, and homes. We're generating a list of lists, and then we split them back up into their units, markets, and homes lists, and that's how we get our populations. So if we go to a market, we can see it's a cell. If we go to a home, we can see that it also is a cell. And a unit is not a cell. So we need to figure this thing out. And I know that a unit is also a cell. Since this is more of a construct, I'm gonna use a circle for this one. So before I connect lines to this, I'm gonna just go ahead and do it. I think it is. Where do we connect it at? I'm just gonna do it right here. I try to make things symmetrical, like this is gonna drive me crazy if I can't connect that. The fact that these lines are not on lines drives me crazy. How about we... What the hell? Come on now, what? I don't even know how people write programs that do stuff like that. And like I said, a unit is not a cell. It's actually an azimuth. And an azimuth is a wrapper of a few other things as well. So we are going to have to disconnect this one. And let's move this guy over here. That will work. Actually, yeah, let's try to make these things like line up somehow. I see what's happening. We were splitting a half of a cell. Half of a cell. That's what I've been calling it in my program. A cell is just one of these little boxes right here. That's all that a cell is in our program. So a cell is that XY function. If we go to what a cell is, it literally is just that. It also is a type. So we have a unit type. It can be a cell, or it can be male, female, market, or home. So that's how we get these unit types. So these are our unit types. And we could, well, okay. We have a unit type. The cell has a unit type, rather. But we also have this unit type that is separate from the home and market type. So, the unit type here has an azimuth. I don't know what changes were made there, but I'm just going to save it. So, the unit type has an azimuth. And an azimuth is, well, a unit has a bunch of other things too, like a state, right? No, it doesn't need a state now. It should not have a state. Or should it? Cell dot state. Cell has a state? No. Targeting system has a state, home has a state. I don't even know. We have so many states. This is not good. That's a problem. We gotta figure that out. The thing to do is to delete all the declarations. That's how I do it anyway. I torture myself. Okay, a unit has an azimuth. An azimuth is comprised of... I hate hiding that. A cell an ethics matrix and a targeting system. Yeah, so this is where we figure out what the state system is doing. I'm gonna grab a snapshot of this real quick. And then just to be complete, so we're not skipping anything because our world has a genome also. And this is actually where we keep the population. Even though we're not actually. We're not keeping anything here. Yeah, this is just ephemeral statistical interface. And it doesn't really have anything. I don't think we even need this here. Yeah, so now we can check out our engine real quick. Because the genome doesn't really have anything in it. That's just purely for the UI or for statistical data graphing. But we will build our genetic evolution out of our genome. So real quick, I'll actually show you what that looks like. So in our genome, we're actually going through and calculating like minimum and maximum. So when we repopulate, we will initially take the second half, like the upper average for maximum age. We want the oldest living generations though. So, whichever, like if the oldest generation 0, then that's fine. But we want to fill up a certain size with that number of generations. So we're trying to reproduce more of these traits. And then out of the ones that we don't pick, we'll kind of like jumble them up. We'll do a little shuffle. And then we'll generate new ones off of those. And then we'll also introduce some random ones, but let's just check our engine. I don't want to go past this level yet into ethics or the targeting system until we get this part. So this is just Pygame right here, really. We could just put Pygame here, and then we could just put genetic learning. Let's just say statistics. Or statisticals. Oh, such a child. Statisticals. Ethics matrix. Okay, so this is where we also really did actually want to figure this out. Forget the world, forget society. The unit level, we have an azimuth. Our cell has some parameters. Our ethics matrix is made up of this. Let's just use regular text. We've got integrity, and then we've got compassion. I'm sure people will really like this. I'm kind of being sarcastic, but okay. It's really not much to this. This is really, let's just say the ethics matrix is designed in a way that gives more opportunities for a lower integrity, but more stable long-term rewards for more compassion, integrity. Let's say the ethics matrix is designed in a way that gives more opportunities for a more negative index and more stable outcomes for a more positive index. That's valid. I would love for people to argue with me about these topics. Because I could feel like there's a ton of people on the internet that would. I think any rational person would not. But most people throw rationale out the window when they get offended. So, yeah, I'm not going to that. So our targeting system, we want to look at that. So we have a pool size. We have a pool. So this is where I wanted to break things down, because this is where things get interesting. So this is where we have our state. This is where we want state to live, I think. But maybe we want it to live in the azimuth. I'm not sure. I think maybe that really is the place. The highest level would be state. But we're allowing the targeting system, well, the reinforcement learning part. Speaking of, our network is here. I really think this is the way to do it. I really do think this is the way to do it. I'm not even initializing this thing anyway. Oh, it's right here. This thing commented out the whole time. Number of targeting outputs. Hidden layers. Reinforcement learning settings. So we've got, there's a lot of things going on here. So our targeting system is supposed to have a reinforcement learning as part of it. I don't know if I want to use inheritance. I don't think I do, because I want to be able to throw this thing away. That probably sounds a little silly, but I need to make sure, like, I think it should be clear enough. Whatever. My head hurts. Let's just finish this dang diagram as much as we can, because I don't think we'll be able to finish the code if we can't finish the diagram. So our targeting system has a pool, and our pool has in targets So we're initially just starting with 3. I think we'll leave it at 3 for now. We have the ability to use as many as we want to, though. So we have a targeting pool. And it has targets, and then we have a... I don't want to use this. Like, these are... I'm using these like lists. This is... should be considered a type. These are also types, but they're like... I'm kind of looking at them differently. Like, a cell is inherited multiple ways for different reasons. These two things don't really exist together or without each other. Like, they do exist together in the azimuth, which is what makes this thing an azimuth. Like, it's a cursor. I don't know how else to, like, describe it. So our targeting system... Let's just assume... Let's use this as our shape. It has an action. Actually, let's use this to represent our enumerations. We have an action. And then we have a state. And what this really gives us is a potential. So if we go to our state definition, we have an action of Wu Wei. I do want to use an action. I didn't for a while, but I want to use an action to try to define what action we're doing. So like at the azimuth level, the self action taken equals let's say from action import action. It's right here. It's like not wanting to see this. Sometimes I wonder why it does that. I was just looking at action. There it is. Action undefined. This is like where you get into the good stuff when you're doing programming and programming languages and stuff. We're gonna get rid of the state at the azimuth level. Oh, we actually don't have it here, so action undefined. And then so if we choose a random action, we'll have to figure out what we're doing. When we choose a random action here, I mean, if self.action equals pursue. No, we can say if self moving, then we can say self action equals action move. I really feel like we should have like a update azimuth. This is where we can simply update the action taken to help us have logging of our logic. Note, this is a projected bias due to my interpretation of the concepts herein. So if somebody disagrees with me, they can suck a fat one. So let's go back to this action. No definition bound. I feel like we should update state and then unit update azimuth. And then unit update reward and then update ethics. That's good stuff right there. That's some good stuff right there. People don't understand how, like, I've never wanted to put my shit out there. Git add, git commit m, just playing in the sandbox. So we want to map out our potential actions. So Wu Wei. Zero. Moving. 0, 1. One, 0. Trading. Eating. Sleeping. Growing. So growing is going to be an interesting one that we implement if we can implement it. Anyway, our potential state. This is wrong. It's not that action, it's the target system action. So we need to say target action. So these states belong to the azimuth. So these trigger world events. When we do these things, we get rewards. So these are environmental rewards. So this is our action state. Yeah, I know these names suck. I know they suck. I don't need to hear that from anybody, just so people know. Nothing is -1. We put it at the end. If you put this at the first, you have to change the if statement in the system. So pursue, pull first. So pulling first will be like going after the first. We're gonna select it essentially. We're gonna change the name of that now. Segundo. It's going to be replaced with Segund. Alright, we're gonna change it to Segun. Segun. This is gonna be a big old graph, but this is gonna be how we determine some state. So it's gonna have a lot of outputs, but it's not gonna know that it will. I'll be yours, I'll be yours. So this flush all one could make it, it could learn on its own not to do this, like if it's trying to follow a target or something, but really we're gonna have it try to stay focused. Like we're gonna try to allow it to, like it might have to choose to pursue it a couple times, but we're gonna try to keep it from only randomly deviating from what it's doing. Like, we are going to make this thing, like, get distracted, get lost, essentially. But, and then every once in a while, we want it to at least forget what it's doing. Like, flush everything that it has in its target queue. So, that's the logic there. We're gonna take... This is gonna take, like, a damn minute to do all this, but I think we can do it pretty quickly. We have to see what states we can be in as well, because we have to choose between so dead state should definitely be both of those are -1. These values don't even make sense. 1, 2, 3, 4. Okay, so we can have those 5 states, so not too bad. We can be alive. So this one entry here is the only one that we have programmed that, as far as I know. Pursuing, I think, just triggers the move. But I don't know if it's doing that because I haven't seen that happen yet. So that was what we were trying to test earlier. We can have broke. We have some of this implemented already. We can have hungry. So the interesting thing is we're not really telling the machine learning what these things are. Like, it has to choose one of these. It has to choose if it's alive or choose if it's hungry. Based on the values that it has wherever they're at in the code. All we're telling it is how much energy it has, and that if it doesn't have enough energy, it dies. That's like the only thing that, and we're not even telling it that. It should hopefully learn to be hungry. Hungry is the first goal, or broke. Figuring out one of those two goals is definitely gonna be one of the big ones. This is gonna take a second for real. 3, 4. Shit, I did that wrong. Damn, I feel stupid already. 2, 3. There's not really a good way to do this. And maybe I don't do them all. But fuck it, I'll do it and not be lazy. Alright, I guess I can't push enter. 4, 5, 6, 7, 2, 3, 4. I might as well do it since I'm actually gonna save this. I'll put this on the GitHub or something. Appreciate everybody's been like supporting me lately, following and hitting me up. I don't know if anybody's on Discord. I'm probably not going to be on there much longer. Gotten some people on TikTok. YouTube's not bad, but just, you have to like promote the shit out of your YouTube. YouTube's like super competitive. It's Google ads on crack. But anyway, there's all of those. Those are our possible So these won't be bad to implement because all of these pull first, pull second, pull third, all those will just be a pull function, and then we'll just drop the first, second, or third. So that's from this pull function. So these two will go from the first pull, second pull, third pull, and like these two functions will plug in here, essentially. And then, yeah, that's gonna drive me crazy. But it is what it is. There we go. And then this will flush all. And then this, so these functions right here, the pull functions, will then pick our other potential state is our selected. So once we have a pursue, and so here's the funny thing, like if we pursue something, this affects, pursuing something affects our moving. Let's have it jump over that one. And then these when we pull one, see, we're not gonna tell it we're not gonna tell the program what to do, essentially. We're just going to let it pick random values from here. And then yeah, this is a lot for me to think about all at once. So trading, eating, and sleeping all depend on the state. So you have to be broke to be trading. In theory. You have to be hungry to be eating. Like, forget conventional wisdom. I'm not speaking to philosophy. I'm just, in terms of this program. And you have to be tired to be sleeping. And then lastly, ooh, we could also pick a motivated state. Eating. And then So we're building a big ass state machine is what we're doing. And then what we're going to do is we're going to create a reward system that changes over time. Once this thing has had 100,000 decisions in its life and it's lived 100,000 lives, this thing should be trained pretty well. Mating. So there's a lot to this too. This is like really ugly. I like this song a lot. Yeah, so it can pick a random action every time. It might want to do nothing and be broke. That might be the right action. Doing nothing and being alive will make them have a wu-wei moment. Doing, not doing. What does that mean? If we did add one more row, we could create an ambitious. Let's call it exploratory. Let's call it an exploratory phase. I really like that. So the exploratory phase will lead us to building things. If we can get basic functionality implemented, it's not really going to do anything initially except take up more time and space, so we're just going to end up like commenting out a lot of these early phases just we will have to test it with this. But yeah, anyway. Really should, yeah, put that in the back. That's pretty cool, I think. And what's cool about this is that we just tell it to pick a random number between here and here. And so, actually, it gives us a set of numbers for the whole thing. And then we pick the best one. There's actually lots of things that we could do with this. We could technically add a convolutional we could do that. We could add a convolutional layer and just iterate. So if you don't know what convolution is, it'll step through all of these values and do matrix arithmetic and give you a single point. Then you do it again here, it gives you single point. You can do them like really big, like 5 by 5, and get one here, and then skip 2 and do 5 by 5 and get one here, and then do it again. You end up with 3 values. I actually really kind of do like the idea of doing that, but then it gets really hard to turn it back into meaningful data. Like, how do you know which action to choose? Typically, you would break it into a segment. If that one had the most, then that you would pick a random value out of that segment. Or you would like combine that number with one of these. I don't know, there's lots of things that you could do with convolutions. Yeah. Yeah, I'm gonna go down a rabbit hole if I even think about that anymore, so. What the hell? Okay, so we're just gonna have it, I almost want to make it just output a single float between 0 and 1. And then just times that by this size. I mean... No, we want to give it, I don't want to think about the number size, but I have to. My head also hurts, so I should come back to this. Oh yeah, I made it big because I wanted to take a screenshot of it. Yeah, I think this is a good idea. So this exploratory phase could get them in trouble, by the way. And it will probably be based somewhat on, the concept of, how can I put this? Like randomness. But it's not really randomness because it's predetermined randomness. I don't know how to put this. I don't know why that had to be so hard, but okay. There's a lot of pieces to kind of think about. And we didn't line out the variables either in the unit. Oh, fun times. All these arrows are backwards. All of them. Except for, okay. I don't even know. I need to go. I can't even keep my eyes open anymore. Yeah, it goes the other way.